Hello guys and welcome back to a new episode in our OpenGL series. Today we are going to continue working on the shader because yesterday we stopped while we were figuring out a way to make the triangle move up and down on the screen. And also guys, sorry for the off camera session of today. It is so because we don't have light in my area right now, so we are going to do a offline session today, but I promise you guys that tomorrow we will continue doing an online session where you will be able to see my face. Anyway, to yesterday we managed to we understood the programmable hardware pipeline that was composed of the vertex shader, the desolation control shader, the desolation evaluation shader, the geometry shader, clipping, rasterization, fragment shader, blending, and frame buffer. We managed to rewrite our vertex buffer in a .vet file and understood the syntax of the OpenGL shading language. We managed to learn about these simple types. This was the update shader, vertex shader program that we wrote yesterday. Is composed of a 3D vertex position variable that is going to be filled in by the vertices registered in our graphic card. This unit float time variable is used to let this first of all, the uniform keyword is exactly the same as the const in proper C language, and here we are just defining a floating point variable. This variable is going to be loaded. It's going to be loaded or changed by our C program. So here we are just making a copy of the vertex position variable data, updating the y-axis with the sine function, and the job of the sine function is to keep this time variable between -1 and 1. So it's a trigonometry function that bounds between -1 and 1, and last but not least, we put our position in a vector and assign it to the built-in GL position variable. And this GL underscore position variable is a built-in variable into OpenGL that is going to that gives us the ability to plot the point, our vertices point on the screen, like to define the position. Yes, to define the position. We managed to do that and to also update our triangle. So this is where we left yesterday. We obtained something like this. If I can, if you will let me open my terminal. Let me see if it's still recording here. Open my terminal. I go to project, OpenGL first. This is it. I think I've already cloned it. Today we are working on Linux machine, so we will do session like this, that we start on Windows, next day we go on Linux, and so we are going to do this. First game in OpenGL. is convenience for uniform. So this is just the convention that the guy that wrote this article uses. We are not going to follow it, of course, because we will came up with our own. So this is the extending shader phase. So this is where we start today. Yesterday we saw that fragment shader is used for pixel sized color. Pixel sized color. This is what fragment shader is. So we have vertex shader. We have vertex shader. Position on screen. Then we have shader so this is what we have here. So it is said here that the hardware pipeline moves at the first exit it gets as output from the fragment shader should be the color of the fragment. The color RGB, red, green, blue, and alpha in that order. The value of each component influence between 0.0 and 1.0, not bytes between 0 and 255, as is common elsewhere. The alpha channel outputs can be used for a variety of effects, such which we define by setting in blends mode in the region. It is commonly used to indicate opacity for a transparent or color blending effect, but by default it does nothing. If you're wondering why we don't set a built-in variable for output color here, is a good question. All the versions of GLSL had a built-in GL flag color variable to set, similar to GL position in vertex shader. When we get into further tutorial, you will see that there is a lot more flexibility for multiple outputs possible now. So this is the new version of the fragment shader. We define a constant time. Here the data is also going to change. Then the output, the fragment, so the output power. This is what we call here a built-in output color here. So the vertex shader takes a set of vertices, and the fragment shader sends out colors for those vertices on the image. So after that we just wild. We multiply by minus, we divide by 2 plus 2, and so what we are doing here is that so we take this in. So we take this in of x. X is the time here. Divided by 2. Plus minus 1 to 1. So if it's 1, if x is 1, is minus 1 is going to be 0. So if sin of x is equal to 1, this is going to equal to 0. But if it's equal to minus, if it's equal to 1, this is going to be 1. So the color still be between 0 so the color still be between 0 and 1. So this is what we want. And the RGB, the color, the frag RGB, this is a way to set it. We set all the value red, blue, and alpha. Red, blue, and alpha to be red, blue, and alpha to be 1, and the green is going to change. So this is what we have. We go into shader, the fragment shader. What we want to do is we declare the wild is equal to the sin of time. Yes. And what we do here is that we take the frag color RGA is equal to a vec3. So a vec3 of 1.0. Then I do frag color green is equal to white. This is what we do. This is exactly what we have. Frag color time. Yeah, so this is. It also has to be called. So whatever we have in the vertex shader has to be in the fragment shader too, guys. So this is also why we call this one time, this variable time. The uniform variable are global to all shaders within the program. So we have accessed our time variable here too. We have accessed. So cell has a mixed up ability. It calls swing link that lets you set any subset component in any order. Because I'm only changing 3 of the 4 components, I'm using a vec tree. I'm using a vec tree here. It's actually an error. I'm using a vec tree. It's just showing a different way to set variable by the component. Yeah, swing. So yeah, the vec tree. Giving a single parameter to a complex type constructor sets all of the components to that value. Here it means that the red, blue, and the alpha component will be set to 1.0. You should get an interesting color animation now. Try setting the other component to a different sign function, perhaps one with times divided by 100 as input. Yes. So, it says that here yes, you should get an interesting color animation now. Try setting the other component to different sign functions. Perhaps this sign function, this one here, this one here. Passing a variable from vertex to fragment shader. We can also output a variable from a shader to send it to the next shader stage down the pipeline. Let's modify our shader to do that. We will specify an out variable in the vertex shader that matches the name of the in variable in the fragment shader. In the fragment shader, the vertex shader, we will specify out to this. Now the post now declared here. The position, this is going to be out. It's going to be sent to the next shader in the pipeline. We do shader stage down in the pipeline. So what we do here is that we take the vertex shader. The position is going to take the vertex shader. We update it. Wait. What it does here is that we define position here. And we update, remove declaration, we update. Here, this keyword tells GLSL that this variable is going to be sent to the next shader stage in the pipeline. So this is what we do. Now we can input that position in the fragment shader. Let's use it as a color, commenting out our time-based code. So what we do is that now we receive in position. position. Now the fragment color is we're going to the position because the position is being updated. The fragment color is going to do the position. What is the problem now? What is the problem? Unexpected hash. What is the problem? What is the problem? What is the problem? What is the problem again? Let's see if I can get this. And specialized buffer is definitely an error. It is not taking. The hash token way. Okay. Guys, I don't know why it's not expected hash token. Preprocessor error. Okay guys, let's find it. Preprocessor error. Processor error, syntax error, unexpected syntax error, unexpected some sort of user's input, so as the mouse cursor position or a uniform to indicate if a button is held on. You can also make them interactive. A handy built-in variable is a variable in fragment shader that you can access to create more interesting effect. glfrag chord gives window relative coordinate on the current fragment. Note that this is in a clip coordinate space, as our vertex, a clip space is the area where our triangle is going to be rendered. It's not a clip space as our vertex position was. But in pixel dimension, if you want the 0.0 or 1.1 range, divide the x and the y coordinate by your view resolution. We set something like 200 and 600 respectively in the hello triangle. Try using this as the output color to get an idea. So, possible extension. Okay. So this is it. So guys, I think we've finished this one. It says here that you can use it. Hot reloading will add an incredible amount of experimental power to your shadow development. An incredible amount of experimentation power. I would recommend adding this to every project where you are doing something creative with shaders. If you add a few interesting uniform variables, mouse, cursor, position, viewport dimension, the time, then you can have a lot of fun with some basics mathematics and some use of scene waves. For some idea of potential, see the shader website, which lets you write and share information written in GLS using version. To create this basic shader, the basics of shader in the website, screen you can either use two triangles or one triangle pages are outside the view area. If you have all of that, then you can actually take a diversion and write a ray tracer or a path tracer. At this point, each fragment will represent one ray, and will write your ray casting code into a fragment shader. We did this at BTF, yeah. So guys, I think this is it. These are just some ideas on what we can do with it. So I think I will leave you guys for today like this, and see you guys tomorrow. Pick up and don't forget to subscribe,